Let's install KVM on Debian 12. KVM is one awesome Linux tool. It's almost dreamy how it houses virtual machines. It's quick and efficient, and in my humble opinion, should be included in the skill set of every systems administrator out there, every DevOps engineer, just about any technician. If you want to run a super powerful virtualization platform on your Linux system, KVM is it. It's a great tool, and I use it all the time. Let's take a look at our to-do list for this video. And so first thing we're going to do is prepare the system. We want to make sure that virtualization is enabled in our BIOS. So preparation is very important when it comes to installing KVM. After we've prepared the system, we'll move into the actual installation and verify KVM is installed properly. Then we'll analyze KVM and see how well it's working and if we can do more. And we'll go ahead and configure KVM for best functionality. After that, we'll set up a KVM user account. And we need that so that we can run commands or run KVM programs. Then we'll view and start the default KVM network. And so this is important to do. You want to have some type of network within KVM for your virtual machines. We'll show how to do this with command line based tools. And finally, we'll also use virt-manager, which is one of the many GUI based tools that you can use with KVM. So KVM is one of the most important tools in my toolkit. KVM is production grade, but it's equally awesome for personal use. Many large cloud providers use KVM or some derivative thereof, something customized, and many more individual users rely on it as well. Either way, KVM delivers powerful Type 1 virtualization. Now, I recently installed Debian 12 to my main system at work, and let's just take a quick look at that. I'm going to run a neofetch here to show the system, just to give you an idea of what I'm actually running on my system here. So I built this system about 7 years ago, and you can see it's an Intel i7-5820K. So this is a 6-core system, 12 threads altogether, running at 3.6 gigahertz with turbo mode available, which I don't usually use, but it's there in case we need it. So it's not the most powerful system and it's fairly old, but we can actually work with this and do a lot with KVM if it's configured properly. We have a GTX 970 video card, which will help with running actual virtual machines with desktops. And we've got 32 gigabytes of RAM. So as I said, we're installing to Debian 12. You can see that here. That's Bookworm. I'm using Fish as my main shell, but the installation will work essentially the same way, whether you're working in ZSH or Bash or what have you. And you can see here I have the GNOME desktop that I'm using. That's my favorite on Linux, although there's other great ones as well. And I'm using Tabby as my terminal. And so that's actually kind of new. I've been using it for a while, but not as my primary terminal multiplexer. And I think I'm going to be using this as the primary one going forward now. So just wanted to give you a feel for my system. You want to make sure you have a fairly powerful system. You want to have at least 4 cores in your CPU. I'd highly recommend 16 gigabytes of RAM or more, and so on and so on. So you want to make sure that you have as many resources as possible on your system. So after years of upgrades, I think since Debian 9 or so, I've this time decided to do a fresh install. This makes things nice and clean for the system, but it means reinstallation of software, such as KVM. So let's get started already. If you'd like to follow along with me step by step, I have a lab document on GitHub, and this is it, and the link is near the video. So feel free to grab that. And this is the KVM installation to Debian 12 document. And the first thing we need to do is prepare the system. We want to make sure that our BIOS or UEFI has virtualization enabled. And as you can see from the image here, my system does have virtualization enabled. It's Intel virtualization. So you want to make sure that that is on. And you may also want to check for IOMMU. And that's something that might be listed separately, especially on servers. Now, this might not be available to you depending on the power of your system. A server or a powerful workstation should have it, but other systems may not. But that's another thing you can check. Another thing you can look at on servers is make sure SR-IOV is enabled in the BIOS. Okay, so that's the first thing you have to do. Need to make sure that it is enabled. You want to have virtualization turned on. That's going to look a little different depending on what BIOS or UEFI you have. So pause the video and make sure that that's running on your system now. But we're good here, and we're going to move over to our terminal and run a couple commands. So first thing I'm going to do is an ls cpu pipe, and we're going to do a grep on virtualization. And so this is capital V, by the way, for virtualization. And when we do so, we should see the virtualization that is running. And so here we see VT-X. So that's Intel virtualization. Linux sees it, and all is good. So that's really important. Need to make sure that it's turned on in the BIOS and that Linux sees it with a command like this. There's several other commands you could use, but this one works fine. Okay, next thing we want to do is update the system. So I'm going to connect as root here. And we're going to run an apt update, $apt upgrade -y. Now, you may not want to update your particular system, but in general, this is a good idea. And I am going to do this for Debian. So we'll do this now. And just fast forward through that. Depending on how many updates you had, you might need to reboot your system. If so, go ahead and do that now. That's generally a good idea after a big update, but I'm going to go ahead now and exit out of root, and we'll continue on. Time to install and verify KVM. So we're going to install the packages into Debian now, and we're going to be using the sudo command. You need to make sure that your account is an administrator. Need to have sudo permissions on this system. So let's check that. We'll do an ID command, and we'll see my user account is dpro, and we'll see to the right here that sudo is indeed on my list. So I am a member of sudo, so I can commit administrative commands into the terminal. You want to make sure that you're a member of that though first. If you're on a Fedora system, that would be the wheel group, but we're installing to Debian, so it's sudo. So we are a member of sudo, so we should be good with that. And we'll type the sudo command and actually install packages. I'm going to be using apt as my package manager. So we're going to do a sudo apt install and a list of packages. The first one that I'm going to install is QEMU-KVM. Okay, so QEMU-KVM is the main KVM program. Plus, it includes user space tools. In Debian, when we do QEMU-KVM, it will select the proper QEMU installation for our system's hardware. So for example, that might be QEMU-system-x86 for an Intel system. That's what it would actually go and install. If your platform is different, then it's going to install for that particular platform. And so that's usually the way that I'll do this. Another method is to install QEMU system, but that's going to install a lot more packages. And it's going to install multiple platform packages. So that's going to take up maybe 7 or 8 times the space then QEMU-KVM. So that's one of the reasons I'll usually go with that. So that's really the main KVM program. Okay. Next on the list is libvirt-daemon-system. And that starts automatically when the system boots and loads the appropriate KVM modules that are required. The next package is libvirt-clients. And this includes various client binaries, including the virsh command, or virtual shell, if you will, which you can use to configure KVM right from the command line. And we'll also install virt-inst. So virtual installation here, or virtualization installation, and that's a group of command line tools that are used for creating new virtual machines, including virt-install, virt-clone, virt-xml, and other type tools. Okay, so another set of user space tools that we're going to work with. And finally, I'm going to do virt-manager, and that is the GUI-based tool for working with and configuring KVM and building virtual machines. So we'll add that as well. Okay, let's check everything. Sudo apt install QEMU-KVM, libvirt-daemon-system, libvirt-clients, virt-inst, and virt-manager. That should be good. So we're going to start the installation now. We'll press enter, and I need to type in my password. There we go. And we see that a lot of packages are going to be installed and 213 megabytes of disk space will be used. Not too bad. Again, if you had chosen QEMU-system, it would probably be closer to a gig of space. But this is good. This is what I want. I'm going to say yes for this and start the installation now. That's going to download and unpack and install everything that we need. And I'll just fast forward through here. Fantastic. It's installed. No errors. Now, sometimes you might get a dependency error or something of that matter, and that's going to require some troubleshooting, but here we are all good. Remember, this is a relatively new installation of Debian 12. I just did it last week, and so everything seems to be running fine here. It looks like it all installed well, but in some cases you might need to troubleshoot or you might need to reboot your system. So let's check the service. Clear this. We're going to do a systemctl and run a status on libvirt-d. That's the main service that KVM will be relying on. And we can see it is active and running and enabled. Okay, so active and running, good. Enabled, so it'll run every time the system runs. Now, that might not be the case depending on your system. So you have to check that. And if it's not set to active, you can do a --now enable, and that will start and enable the service all in one shot for libvirt-d. Okay, so you want to make sure indeed that it is active and running. Okay, let's do some more verification here. I'm going to run the KVM --version command, and we should see that the QEMU emulator is installed, and we do, and we're seeing version 7.2.7. Okay, good. Thank you so much to all of the developers that work on KVM, QEMU, libvirt, and Linux in general. Okay, awesome so far. Next thing I want to check is virsh and see if that is up to date, and that is installed to version 9. So we are fairly sure that the three main components of KVM are installed properly. That's KVM and QEMU and libvirt. So those are all there. Plus we have user space tools, for example, virsh and also virt-manager. And just because it turned blue there, I know that that command and program will work on this system as well. Awesome, and that's part of the beauty of the fish shell. Good, excellent work. Our KVM installation should now work properly, but if you need to, reboot your system and we'll move on to the next step. Time to analyze KVM. We'll start with this command, lsmod, and check if the KVM modules are actually installed and running. And we'll do that with a grep on KVM. And look what we have. We see the KVM module and KVM Intel module. So that looks good. Now, if you don't see anything when you run this command, you may need to reboot your system. But you should see the modules at this point if you're doing this on Debian 12. The next command I want to run will allow us to see if the various components are available and how they're working in KVM. This is an important one. We'll do a virt-host-validate. Press enter for that, and you'll see a long list of stuff. Now, the items that I'm interested in here include the QEMU items. We also have LXC items for containers, which is totally cool if you want to use, but this video is about KVM. So we're interested in the QEMU section, and you want to have as much pass as possible and no warnings and no errors, right? Now, the really important one that I am interested in here is IOMMU support. We want to make sure that we have IOMMU support and make sure that that is passed. So this stands for Input-Output Memory Management Unit. You want to make sure that if you have this support within your system, that it is passing here. So this connects your DMA capable I/O to main memory, and it allows for things like PCI pass-through. And that's going to become really important when you're running virtual machines that have a desktop and you want to make use of your graphic card. Right? So that's going to be really important to you. It's also memory protection and more. If this doesn't pass, then your virtual machines will probably not perform as well as they should. So this is something that is possible to enable in the BIOS, and you might have to enable it in Linux as well, depending on your system. And so that's something that we'll do in the next section. It is actually passing here for us. We're in good shape with IOMMU, but we'll show how to set that up in case it doesn't pass. Let's make configurations to our system so that it can run as well as it possibly can with KVM. And so I'm going to make some modifications to the grub file in Debian. So I'm going to do a vim on /etc/default/grub, and we'll modify that file here. And actually, I'm in read-only mode, so I'll do that again with a sudo. And the line item that we're looking for here is grub cmd line Linux. And we want to add a couple items to this. And you can see I have one in here already. But here's what you could do. You could just space every item that you want to add in there. And there's a couple things that I want to add because my virt-host validate was not really clean. I want to make sure that it's as cleaned up as possible. So first thing we can add is that support for IOMMU. So as I mentioned, IOMMU is the Input-Output Memory Management Unit. It takes care of connecting DMA capable I/O. It allows for PCI pass-through, and again, must be enabled in the BIOS. If you have virtualization turned on, it might be enabled automatically, or it could be a separate setting. But we can add support for Linux in here, and we would do that by doing an Intel_IOMMU equals on. And so that should run at that point. I don't necessarily need to because that passed already, and that's part of the beauty of Debian 12. That would not have passed on Debian 11 or 10, but now it does automatically. Okay, so a couple other things that failed for me within LXC includes devices and freezer. And there was warnings for those for QEMU as well. So we can add those as C groups. So we could do a cgroup_enable equals devices and a cgroup_enable equals, the other one was freezer. Get out of insert mode, save and quit that file. And so we'll do a sudo update -grub. Okay, need to do this with administrative permissions, so we need sudo rights, and that updates that. And this is all part of going for that clean virt host validate command. Now, part of the problem here is that the virt host validate command and program is somewhat deprecated because it tests for cgroups version 1. And with most versions of Linux, you're dealing with cgroups version 2. So there's a couple workarounds here to make this look better. First, if we look here, we see we have a warning for devices. Now, I'm just running this command as a standard Linux user. And if I was to run it as root or with sudo, that will probably pass. Then we have a warning for secure guest support. Well, that has to be configured more on my system. And indeed, it may not even be available on many systems out there. Then down below here, we have two failures. We have one for devices and we have one for freezer. Well, once again, for devices, that will probably show up when we run this command with sudo, and freezer will probably show as a fail consistently because it's using cgroups version 1 to view this information. The currently used cgroups version 2 in Linux, that interface has a unified set of controllers. So the ability to freeze processes of a cgroup is now just part of the baseline cgroup interface in cgroups 2 instead of being a separate controller. So we're not really too worried about that failure right there. In addition, that's for LXC, which I'm not even setting up right now. I probably will use it later, but I don't really foresee any problems. So this command's pretty good as far as the basic hardware virtualization and finding if KVM exists, and especially if IOMMU is running. But for other things, you might not be getting completely accurate information. So for example, if we go to another terminal here, and I have this split, I'll do a sudo virt host validate. And when we do so, let me go full screen on that, we'll see that indeed devices here for QEMU has passed. And also devices for LXC has passed. We just have the one warning now for secure guest support. And then we have that failure for freezer. But again, the reason behind that is because we're dealing with cgroups version 2 now, where everything is unified and individual controllers aren't really required. And it's not really giving a proper test here. LXC should work properly. And so likewise, if we go to a root shell and run a virt host validate, we should get the same information. And in fact, we do. So if you run it as root or if you run it as sudo, you're going to see different information than if you run it as a standard user, because the standard user can't see the results of some of these tests. But there is a couple of other things that I like to do on the system to make sure that it's running properly. And one of those things is to run a systemctl status. When we do so, we see here that it is running green. So green is good. If it says degraded in red, then you know you have a problem. And hopefully it's not related to KVM. But either way, you want to chase that problem down and see what it is. So this is running. It's all good. And I'll also do a systemctl --failed sometimes, just to make sure there are no failed services or scopes or slices or units or anything else. So 0 units listed when we do that, and it is running properly. So a couple of checks that you could do after you do your KVM installation. Let's set up our user account to work with KVM. And to do that, we're going to add them to the libvirt group. So I'm going to do that now. We'll do a sudo and we'll do a user mod -a capital G. And then we want to add the group, which is libvirt. and the user in question, which is my user, dpro. Now, I'm an administrator, so I can add myself to anything, but if you're not, then you'd have to add the user account as an administrator. Or if you wanted to add a separate user account to libvirt, you'd have to make sure you do it as an administrator. I am, and I'm using sudo, so this should work. And at this point, we could log off and log back on, or instead of that, we could do an exec su-l and dpro. Type our password in here. And that effectively refreshes our session and should show any new groups that we are part of, which is indeed here now we have libvirt. So we were a member of sudo, but not of libvirt just yet. So now we are, and we can see that because I connected back in with my shell. If you don't want to run that command, you could just log off and log back on. But the main thing here is that you make sure that the user account that's going to work with KVM is a member of the libvirt group. Now let's show how to view and start the default KVM network. And we need to have some type of KVM network for our virtual machines. So let's go ahead and run a couple commands here. First, we'll start with a virsh, and we'll do net-list. Now, if you don't see anything here, that's okay, because by default, in a Debian installation of KVM, the KVM networks are not running. Even the default network, and that's the actual name of it. So if we want that, we will first have to start it. And so we'll do a sudo virsh, and we'll do a net-start, and the name of the network, in this case, default, which is the built-in one for KVM. So we'll do that now, and here we go. The network named default is started. So if we do a list once again, we will see, yep, default is now started up. It is active. But it's not set to auto start. So it won't auto start every time we reboot our computer. And generally, that's what I want for my main KVM network. So to do that, we'll do a sudo virsh, and we'll do a net-auto start on the name of the network, in this case, default. There we go. Now network default is marked as auto started. If I run that netlist command again, we'll see now indeed the default network is active, and it's set to auto start every time we restart KVM or restart the computer. Quite often, best practice is to apply these changes, and we'll do that with a systemctl restart libvirt-d. And if you're not using sudo, authentication will be required in the GUI, so either way, but you will need to show that you are an administrator that can do this type of thing on the system. Okay, and we'll do that virt-netlist one more time. Everything looks good at this point. And by the way, if you want to learn more information about a specific network in your KVM setup, you can use the virsh net-info command on the default network, and we'll get a little bit more detailed information, the universal unique ID, the default bridge that it's using, which is actually very important, and whether it's active, persistent, and set to auto start. And you can do that for any of the networks, or do your virsh netlist command if you like. Okay, so there's a little bit of the commands in the command line for KVM, and in the next step we'll work in the GUI side of things. Let's go ahead and open the virt-manager program, and I'm just going to type that now. And here it is. That's the GUI-based program that we installed. Now, if you have any issues with this, you never know, you might need to log out and log back in, or perhaps you did not install the package originally, but it should work at this point. You want to make sure that you are a member of libvirt or an administrator on the system to be able to run this. And you'll see inside here, it just says QEMU/KVM. That's it. But let's take a look. Let's go to Edit and go to Connection Details. and then we'll go to virtual networks. And you should see the virtual network that is running by default here. The default network is simply called default. And you can see that it is active and it's set to auto start on boot. And that's because we did those things in the command line, but you could select that here as well if you wish. The default IP configuration for our network is 192.168.122. That's the NAT network that KVM uses by default. It also incorporates a built-in DHCP server, which gives out IP addresses between 122.2 and 122.254. Keep in mind that the device that does this is a built-in host within KVM. It's on 192.168.122.1, and that acts as the gateway out to the internet or wherever it is that you need to go. It also acts as a DNS resolver and, as we're showing here, a DHCP server. And you see that we are utilizing network address translation here. Okay, and this is the tool that we'll use to create our virtual machines. So I'm just going to close out of that connection details window. From here, we could go to File and go to New Virtual Machine and start creating virtual machines to our heart's delight. And I'll do that in another video. But there we go. We've got KVM set up and ready to rock on Debian 12. So there you go. Now you know how to install KVM to Debian 12. Go forth and use it. And so check out the companion article at prouse.tech. And until next time, thank you for watching.